Welcome back to Bits and Pieces, lecture number 3, Minecraft Bitmatic. So before the break we took a look on a simple block there. We used some bits there with a metadata, and we also used some binary and bitwise operators when it comes to the damage value in an item. And obviously we weren't done, and I'm just going to continue with that and see what we can do with it. So let's get going. One thing that we didn't do was to give it any textures, and to do so I'm going to use the charger texture here together with the charger colors like so, and I've prepared those as well. So in here we have charger blue, charger green, charger red and charger white like so. So I'm just going to add them, and then we'll see some other neat effects that we can do, and then when that is done we're going to add more functionality. Because, well, it's annoying to just have black and purple squares. It's tricky to see what we're working with. Okay, so what do we do? Well, we need to register the icons. That's the first part. Let's do it here. So register icons like so, and what we need is of course a array for the icons like that, and that's just a matter of well, importing icon like this. No, not that one, sorry. The Minecraft one, obviously. And here it's going to work pretty similarly to what we did with the blocks, but here we obviously just have one array for the icons, not two that we have for the block sides, because there we had a side one and a front one. Here we just have the very icons for the different colors. Icons equals new icon, item info dot charger colors like so. Just refer to the length there. Like so that's the array, and then we can just loop through that and add it also. Oops, for hint I, sorry about that. It's less than icons dot length, and increase it like so. And here we do what we have done earlier many times before actually. Icons like so equals register the icon, get the texture location, item info dot texture location, add a column there. And then what we want to do is add the prefix, which is item info dot charger texture, but then we want to add the color as well. What I want to do with that is item info dot where is it, charger colors like so, at a specific index. But of course I want to convert it to lowercase as well. I had an uppercase ladder in the beginning, so it would be looking nice when we printed it all out like that. And it complains about these things. Oh, well, no, it fixed that just because it was saved and everything. I thought I didn't save the information file, but of course I did. So there we go. I just add the texture location, a column there, the prefix there, and together with the color like so. Okay. So there we go, and the colors here, if we take a look in item info, are only names like so. So those are only the names, and we refer to those because that's what these icons are called. So we have charger blue, charger green, charger red, and charger white. So those are only the names there in that array. Sweet. Okay, so what's the next step? Well, we might want to return the correct icon that we're using, and that's actually very simple, believe it or not. Get icon. Where is it? Here we go, from damage. So we get the damage value. That's very convenient, and that's the reason why we're actually asking for a damage value here instead of a item stack itself. So we can just get the damage value there and use that. So return icons like so, but not a damage value obviously. We want the get active color like that, with the damage like so. There you go. So there we go. Now we have icons which represent the proper and active color there, but I'm not entirely done. I want to do one more thing, and what I'm going to use are these color tags that I have made. And if you didn't take course 4, you might not recognize these, but we'll take a quick look at them. But what I basically specify is that we have GUI color white, GUI color red, GUI color green, and finally GUI color blue. And what these are something that I set up, like I said, in course number 4, the one about interfaces. And we can use that still, even though it's called GUI color, we can still use it. It's nothing special for GUI really. And what we have are these different colors that we can have in when it comes to Minecraft strings and Minecraft texts for well, not any strings, but basically names for items, name for blocks, you know, mouse over effects. That's where we used it last time. We used it for mouse over effects. So if we just have these different things here, and since we return integer to hex string like so with the number and add this character in front of it, we'll get the proper color. And we're going to use the same thing now to just well, make the description there a bit better. It's going to look a bit better. So we just go to, where is that, the add information here. So what I want to do is simply, well, when I say, alright, the current active one is red, then I want that to be in red. If the current active one is blue, then I want that to be in blue. And that's fairly simple, actually. It's just item info dot charger color tags like so, and then we just refer to this index that we get as the current one like so. Here we go, like that. And just because that is set up properly, that's going to give us the correct color. But we can do the same thing for the uses left here, and we could well, do that for the whole line here, but that's going to be a bit too much of the colors. I tried that, but it just looks weird. So what I'm going to do is give that to the name and the uses that we have afterwards. So I think that's enough with those colors there. And what do we do here? Well, item info dot charger color tags like before, but here we just refer to I instead, like that. So we add the color tag and then the color name, and then we add the uses like so. So now we have an icon that should be dependent on the current active color, and we should also have some colors in the descriptions to make it easier to read. But we will have to make sure that we don't have too many colors, then it will just be tricky to read due to all the colors. Let's take a look. Here we go. So now we will much easier see that we actually do the change when we do shift click there. So there we go. Now we have the color charger like so, and if I hover there, we'll see that active color white, uses left of white 7, red 7, green 7, blue 7 like so. So we're still not changing that, but now it's easier to see the different things there. If you want to, you can add more colors, but I think it's quite alright with the colors we have. If we wanted to, we could remove some colors as well if we wanted to. And now if I shift click here, we get the red one instead, we get the green one instead, and if we take a look in the tooltip, we can see that on the first line it's actually saying green in green, and then we have blue there like so. And if you want to be evil, then what you could do would be simply to write white but type it out in red, but don't do that. So there we go. Let's go back to Eclipse here, and what's the next step? Well, we have done the aesthetic things here. We can change the active color, but we can't apply the color to the actual block, and that's the next step. Remember, we had a block and that can actually control its colors, but we can't change it. So if we just tell the block to change the color, it's actually going to be able to handle that because we have that code already. Let's go back to block color and take a look here. We're actually considering the color already, but like I said, we're not changing that. So how do we do that? Well, here we go. If the player is sneaking, then we want to do something, right? Then what we want to do is change the color and so on. But if the active color, that is. But if we don't sneak, then we might want to take a look if world dot get block ID, if that at the current position is the same as block info dot color ID. What does that mean? Well, that basically means that you just clicked on a color block, and if you just clicked on a color block with a color charger, then we might want to, well, modify its color. So that's the first thing to check. And what do we want to do? Well, we want to do a few things here, but to be able to do those properly, I'm just going to ask it for what is the metadata at a specific location. We can just do that. Get block metadata, because we of course have the world and the coordinates like that. Well, we just use them for the ID. So let's grab that. And we might want to modify this metadata. So we want to modify the metadata if we want to change the colors, but as you might see very soon, we might not always want to change color. There are two cases where we do not want to change the color of a given block. Can you think of which ones? So now I want to do int item color equals get active color. Okay, so the reason why I do this part here is just so I don't have to call the get active color all the time, so I can just refer to item color as the current one. We could call the get active color all the time as well, that would be perfectly fine, but instead I'm just saving it there. I guess the same reason why we save metadata there as well. Okay, so what do we want to do now? The two cases, what are they? Well, one of the cases is, well, if we don't have enough charges in this specific color, then we don't want to add this new color. So if we want to apply red to a block, but we don't have any red left in our charger, then, well, we can't apply red. We don't have that color anymore. The other thing that we want to check is to make sure if we want to apply red and we're trying to apply that to a red block, then we do not want to apply that color at all, because, well, the block is already red. There's no reason to apply it and, well, deplete one charge from the item. So those are the two things I want to check. The first one is the following. So get uses for color. We give it the damage value from the item, and then we just give it the color we want to check. Which color do we want to check? Well, of course, we want to check the current one, which is stored there in item color. So we want to make sure that that one is greater than 0, and we also want to check that the metadata, and then we do this thing here, 0b0011. Remember, that's where we store the color, these two bits there. So we want to get the color from the metadata and make sure that that's is not equal to the item color, because if they are the same, then we don't want to change. So we need to have at least one charge of the given color, and we need to make sure that we're actually trying to change the color, like so. And if we manage to do that, or, well, if both of those things are true, then I want to return true, because we're going to do something like so. Right, so what's the next step? Well, the next step is obviously to actually do this change, and that is actually the easy part. We're going to need to do more advanced parts than this thing here. But how do we do it when we want to set something? You should know this. We remove the old color, apply the new color. So meta and equals to not, and then we do 0b0011. That's not a not. I'm using the wrong key all the time. Silly me, like that. So that's the same mask that we have there, but we invert it and we do an and there to remove the old color that we do have. But we have the current color and item color, so we can just apply that like so. Very simple. We don't have to move anything around, just because, well, we have the two least significant bits like that. Okay, what's the next step? Well, the next step is, of course, to apply this as the current metadata. Set block metadata with notify x, y, c, like that. Give it a new meta, and there we go, a 3 there to notify it properly. So there we go. We're not done. So what we have now so far is actually what we might think as the core part. What we're actually going to do, we change the color. Well, that sort of is the core part. That's what we're trying to do, but that's not the most advanced part. What we need to do is two more things. First of all, we need to deplete the charge of the correct color, and second of all, we need to make sure that, well, if we don't have any charges left, then we should destroy the item. Okay. So how do we do those things? Well, we could put the code here, but just to keep things organized, I'm going to put a method here that we're going to use to reduce the charges of the current item. So how do we do that? Well, it might get a bit tricky, so what I'm going to do is just do the following. Reduce active uses. So if we give it a damage value, then it's going to return a new damage value like so. So then we can modify the damage value and send it back. And then when we call this method, if we want to, we can apply the damage value that we get to the item stack again. Maybe we just want to go to preview it. I don't know. So it's just a method here. What we're going to do is just give it the current damage value and set the return value as the new one. So we could, if we wanted to send the item stack along, just modify that right away. But the reason why I go with the damage value here is just because I've done that before for the other ones, because there we actually need it. So what do we want to do here? How do we modify the damage value to reduce the active uses? Well, first of all, we need to know which color is the active one. So get active color from the damage there. And then what we want to do next is, of course, get the uses for that. Get uses for color, and we have the damage value and the active color like so. But of course we can reduce that by 1. We should, after all, reduce the active uses, like so. So that's the new uses that we do have, and now it's just a matter of actually replacing these things. Remove the old one and add a new one. And this is sort of what we usually do. We need to think a bit further though to make sure that everything works. Okay, so how do we remove the old one? Well, we need to do damage and equals to, and then we need to invert everything but the mask. Well, we need to invert the mask like so. So we end that with everything but the mask itself. So what is the mask? Well, 0B11100 seems like a good start, right? That's the one we have there. But we also need to move it upwards, right? So we need to move it to its proper location, and we can do that fairly simple actually. So if we split these things into different parts and take them one step at a time, it's not too tricky. We have this mask, it seems like a good base. We have the zeros there to not affect the active one, the active color from there, and then we have the 3 ones there for the 3 bits for a specific color. We move it up the active amount like so, times 3, just because 3 bits per color, and there we go. Now we remove the last well, count of the uses. So if we had 7 before, we reset that, so now we have zeros, and therefore we are ready to apply the new color, which is of course damage or equals to uses, like that. Is that correct? No, of course not. We need to move the uses to the correct location, and well, move that up with active times 3 like before, but we also need to take these two into consideration, and therefore we add an extra 2 like that. So what we're doing here is we get the active color, we get the uses for that color and subtract it by 1, we remove the old count of those uses, we apply the new uses, and then return the damage value like so. Let's scroll down to where here we go. So what do we want to do here? Well, now it's fairly simple. Now we can just refer to that method. So set item damage to whatever we get from a reduce active uses like so. But we need to give it a damage value as well. So just stack.get item damage. So what we do, like I said, we get the item damage, we send that to reduce active users, the result from that we set as the item damage as well. So we just send that through the method, and that's going to reduce the active users for that item like so. Are we done now? No, like I said, we wanted one more thing. What was that? Well, that was a way for it to actually get destroyed when we were out of charges, because you won't be able to use it if we don't have any charges of the current color. But if, well, all the colors are completely depleted, then we can never set it into a valid color anyway, so the item is completely useless. So how can we do this? Well, what we could do would be to loop through all the different colors and check if their uses if their uses were more than 1, well, more than 0, if we actually have any uses left for that specific color. That would be a possible solution, right? We just go through, so we check, do we have any uses for for white left? Do we have any uses for red left? Do we have any uses for green left? Do we have any uses for blue left? And then if we find a use somewhere, it doesn't matter where, then we can say, alright, we have uses left, just, well, continue, don't break the item or anything. That's a possible solution, but that's not the solution I'm going to use. What I want to do here is if stack.get item damage, let's take a look on this, like so. So I get the item damage. What do I want to check with the item damage? Well, first of all, I actually want to type if there. But second of all, what I want to do is make sure that we don't have a bit that is 1 at any of the uses. Well, there are bits there that is defining the amount of uses. What does that mean? Well, that means that if we have zeros all the way there, then we're out of uses. Why is this a good way? Well, we don't really care about where we have a use left, how many uses we have left for that specific color or anything. We just want to check if we're completely out of uses, and we can do so like this. So 0B and then 111 for color 3, 111 for color 2, 111 for color 1, and 111, was that the correct amount, for color 0. So that they have 3, they have 3, 3 and 3, yes, it's correct. And then those 2 zeros there, we don't want to bother about the active color. So well, otherwise, if we had 1 and 1 there, we would actually have to have the active color as being white to make it break, and that seems like a very ridiculous way of having it. So now if we get the data from there, we can just check, alright, if that is equals to 0, like so, then we want to break the item. How do we do that? Well, stack.stack size and subtract that like so. and that's going to break it. So we just make sure that if we have a 1 anywhere here at that specific location, then we will get something in the result when we do get item damage and this long mask here. And if we get something, then it's not going to be equals to 0, and therefore we won't break it. So all the time we'll go through this if statement and just jump past it until we reach a position where we have zeros all over the place here, because then the result is going to be 0 like that. So let's take a look on the result here. What we have is we get the metadata and the current active color. If we have enough uses and we actually want to change the color, then do change the color. Save that new thing there and reduce the amount of uses we have. If we don't have any uses left at all for the whole item, for all 4 different colors, then destroy the item as well. Let's start. Here we go. Right, so let's take a look. Okay, so now we have the full charges here. It's white and everything. I placed down a few here, 3, 4, 5, 6, 7, 8. There you go. That will have to do it. So now if I click here now, it's not going to do anything. And that's because I have the correct color. And just because that is the case, I'm actually going to return false. Because we reached that one, return false in the end. Just because that one returns false. And what that means is that I can actually change the side here, like so. However, if I change the color, like shift clicking like that, so now it's red, and click there, it's not going to change the side just because we return true. And therefore, when we return true, what that means is basically don't send this information to the block itself. So the block won't be activated because we return true. And that's exactly what we want, because when the block is activated, the side is actually going to be changed. But if we want to modify the side with the same color, we can just do it like that. There you go. Okay. And take a look. How many reds do we have? Well, we only have 6 reds left because I've used it once. If I use it again, we have 5, like so. I can change the color to green, for instance, and apply a lot of things here. Look at that. I can't apply anything more because we don't have any green charges left. Look at that. There's no line for green because we just ran out. Let's modify it to blue. Like that. I ran out of blue colors as well. Like that. Shift clicking to white. Let's use the white colors. Like that. I just ran out. And now I have 4 red uses left. So 1, 2, 3. So now I should have 1 use left there, and if I use it there, it's going to break because all of a sudden we don't have any uses left whatsoever and the item was destroyed. So then we can craft a new item, or in the case of this testing here, we can just grab a new one from the creative window like so. Pretty awesome like that. And of course, if we use the item here, so I just used some charges there, change it to that, and then log out and log back in again, what's going to happen is it's still going to have the information. Yes, because we store that in the damage value, and the damage value is going to be synchronized, so that's nothing we have to bother about at all. We never have to bother about saving things when we work with items. Okay, so far so good. It seems like a very nice thing what we're doing here. In the metadata, what we have is that we store, instead of just 1 number, we store 2. We store 2 2-bit numbers, 1 for the color and 1 for the side. In the item itself, we store actually 5 different integers inside it. We store, where do we have them all? Up here. We store the active color, which is a 2-bit long integer, and then we store 4 different integers that have 3 bits each. That is going to define how many uses we have left. So instead of just being able to store the type itself, maybe you would say, alright, we can store the type there and then we're done. Of course not. We use 2 bits to store the type, then we use 12 more bits to store 4 different use amounts. So here we have a very nice use of bitwise operators, where we store all of the data here in just one one short there. Well, it's 15 bits, not 16, like that. So it works fairly well in my opinion there. But obviously this color deploy doesn't do anything, so I'm going to add a very simple usage of it. It's not going to be perfect, but it's going to do the trick, I guess. But let's do so here. Okay, so we've seen this example in earlier courses as well when we want to do something on Redstone activation. And here we go, on neighbor block change, we get the world X, Y, Z, and then the ID, like so. Okay. So what I want to do is, when you give this a redstone, then I want to play, not to play, but place a block of wool at a specific side that we have defined and with the specific color that we have specified. We're going to see some issues with these that I'm not going to fix. They are fairly simple to fix, but I'm just going to make a very basic version. So first of all, we want to check that the world is not remote, so it's the server side, and finally world.isBlock indirectly getting powered, so that checks if it has a redstone signal. However, just because the neighbor block has been changed doesn't mean that it just received a redstone pulse. So now it will be able to place multiple blocks just because, well, you've modified a block nearby, and that's probably not what we want to do. Maybe we do want to do that, and then we can just leave it. Otherwise, what we'll have to do is store the last redstone state. So what we want to do is just see, alright, we didn't have a redstone state the last time we checked, but now we do. That means that it has been updated and we just got the pulse. Something like that. And if we want to check if it's turned off, then we just check, alright, we had a redstone pulse last time, but now no, we don't, if we don't want to do something when we loses the redstone pulse. But where would we save that data? We only need one bit for that. Like, what was the last state? Was it 1 or 0? Or if we want to use analog redstone, you know, from 0 to 15, then we would have to use 4 bits. We don't have any room for that in the metadata. That's full already. We use all the 4 bits we have. And therefore we would have to use a tile entity for that value if we wanted to add it. And then you might think, if we have a tile entity, we could just store whatever we wanted. Why would we even bother about squeezing these things together? Well, you might forget about one important thing with the metadata, one very nice thing with them. They are synchronized between the client and the server in a very neat way automatically, so we don't have to bother about that. So the redstone data, like the last state there, do we have to synchronize that to the client? No, we do not. Do we have to synchronize the color to the client? Yes, we do. We want to show the color on the block. Do we need to synchronize which side is the active one? Yes, we do. We want to show that on the block as well. So now we're squeezing all the data that we do have into the metadata that we want to synchronize. Of course, we could put it in the tile entity and synchronize it manually, but that result wouldn't be as good as what we have. And also, there's no reason to not store it in the metadata, because if we store in the tile entity, we have to save them and store, well, more data anyways. If we have things in the tile entity, well, it works, but we still have to well, save it, and therefore we're going to save more data than what we're going to do if we just compress it into the metadata like that. But that was just a little side note there. I'm not going to bother about that thing, so what we're going to do is just place this wall block no matter what. Get block metadata like so. And this metadata is obviously going to contain all the information that we need, which side to spawn it at, and also which color to spawn it with. So inside equals meta and there we go, 0B1100. That's where we find the side, but we also need to move it down 2 bits, just because we can find the side up there and not down there. Okay, so what's the next step? Well, we might want to do the following. So target x equals x, and int target c equals c. So we just define 2 variables here. Target, there you go, where we can store, well, where we want to place this wall block. Obviously we don't want to place it at X, Y, and Z. If we do so, we will just replace the color deployer itself, and that seems a bit weird. If you want to, you can totally do that. So what do we want to do here? Well, let's do switch side, and depending on the side, I'm just going to modify target X and target C to be able to place these properly. So if we have case 0, then what we want to do is target C minus minus. It might be a bit tricky to know all of these things, but to like which sides to use. So what you will have to do is just log into Minecraft and check which directions correspond to which well, coordinates directions, I guess, which sides there. And then you can also trial and error, so if something goes wrong you can just modify these. But yeah, I've tried it already, and these are the values we want. So case 0, then we want to decrease the C value there to put it correctly. 1 should increase it. Case 2 should decrease the X value like so. And this is of course just how the cases are defined. It's not really anything we can change about these. There we go. So I'm just going to modify the target like so, and this is going to be defining where we want to place the block. Then we can just use target X, Y, and target C. So we want to put it at the same Y value as well, we have the color deployer as we just place it to the side of it anyways. Okay, so the next thing I want to do here is define the metadata of the wool block. The metadata of the wool block is of course defining which color it has, and the color a wool block has, it's not defined with the same values as the ones we use. Obviously we just use 0, 1, 2, or 3, whereas a wool block goes from 0 all the way to 15, because a wool block has 16 colors. We're just using 4. The good thing that we're just using 4 is that we can just use 2 bits, whereas the wool block needs to use all 4 bits for the colors. We want to use the other 2 for the direction, of course, or well, this slide like we did there. Okay, int color equals meta and 0b0011 there, so we get the color there. And what I want to do here is simply switch like so. So I want to do a switch here depending on the color, and depending on the color I'm going to set the wool meta differently. Wool meta equals 0, and then we have a break there. Alright, we are at exactly bottom of the screen. There you go. Case 1, wool meta. So this is the red one, and the red metadata of the wool block is 40. How do we know these values? Well, we can do 2 things. Either one option is to check if in the code, like what are the different metadatas in the wool code, and the other one is just check the Minecraft wiki. You can just check it there. It all says what different metadata the different colors have. So then we have the green one, which is 13, and finally we have the blue one, which is 11 actually, like so. So now when we have set the correct wool metadata and this correct target, we can just use that to well, set the block. World dot set block, that one. So target X, Y, target C, we want to give it block, and the wool block is actually called a cloth block in the code, so we need to refer to cloth there. Block ID wool meta, like so, and then a 3 there for the update thingy there. That's because we have the metadata with us, otherwise it would do that automatically. So as you can see, we have some issue with this. We don't get the wool block from anywhere. We just spawn it. We don't have to put it in an inventory or anything, and then it would colorize that wool block or whatnot. We just get it for free. The second part is, of course, we don't check that it's actually an air block there. We're just going to replace whatever we're actually having there to start with, even if it would be a bedrock. And the third thing is, of course, that the Redstone code is not perfect. But like I said, this is just an example of what we have done. I don't have the time of doing those things. You can do those yourself if you want to. The source of this is, of course, on the lecture page after the lecture. Let's try this. Here we go. We should see that it's actually working. Well, hopefully it should be. And to do so, I'm just going to use a simple button here. Okay, so what do we have now? Well, that side is the active one. I put a button here, and I hit press, and we get a white wool block there. If I change the color to red and click it again, as you can see, it turns to red. The reason is of course that we don't care about that we already had a wool block there. It's just going to replace it. So let's use that one. I'm going to change the color, put that to green, and place a green block there. Then what I want to do is change the side there, give it to blue like so, put it like that, change to white, and change the side to this location there, and then just replace the button like so. So there you go, that's the result of this color deployer here. Of course it's not perfect, but we have seen quite neat examples on what we can use the bitwise operators for. We've seen how we can store 5 different integers in the damage value here, and we still have 1 bit to go that we're not using, and we've seen that how we can use the metadata and still store both the color and the direction of that block. So we're done with this example. I'm going to show you one small example before we end this lecture and this course, and that's going to be with hexadecimals and and colors. So first of all, I want to place this floating droid from the previous course. If you didn't take that course, it doesn't matter. I'm just going to show you what's happening here. We have a core there, that spinning core there. If you saw it, I can grab some more. I'm just going to place them there. As you can see, it has different colors. There we have a red one, there we have a lime one, a dark blue, light blue, and so on. And well, the way we randomize this value is a bit annoying, I guess, and we'll take a look on that in the code. I'm going to modify how that works slightly. So I just wanted to show that if you haven't seen that already. So that was what we made in course number 5. Okay, so to do so, I'm going to open some files here. Entity droid, here we go. So the color here is defined by RGB. So the red component, the green component, and the blue component, and we store that into floats. And then we randomize those there, so we randomize all 3. And then what we do is, of course, return all 3 like that. And then in the rendering code that we also have is, of course, where's that render droid here? Then we just grab all of those 3, like so, droid get red, get green, and get blue color, and then finally we send that along to the model itself, where we apply that color, so we get the core, scroll there, core red, core green, and core blue. So that might be a bit annoying if we want to have multiple sets of colors and so on. Then we would have to have multiple sets of RGB here. So what I'm going to do is show an option to this using hexadecimal and bit shifts to an easy way. Just put everything in just one integer value. And this is not something I just invented. This is something that is very common, and we'll actually take a look on that we've done that already if you have followed along these previous courses. But first of all, let's go to the model droid here. And instead of asking for 3 floats, I'm going to ask for 1 integer instead. Int color, like that. Is this a good thing? Well, if we're just concerned about the data that we're sending, then it's actually a good thing. A float, we haven't been talking too much about how they are saved, but they are using 32 bits to save a float. An integer is using 32 bits. So instead of having 3 floats, we have 1 integer, which is a third of the size. The size, however, doesn't matter too much when it comes to, well, just sending the information along here. But it becomes much easier to just send along 1 value rather than 3 different components when we want to send colors along back and forth. We'll take a closer look on that in a second. But of course, we need to refer to, well, the components part here. So I'm actually going to calculate them from the color there. Okay. So float red equals, okay, how do I calculate the red part from that? Well, what I want to do, and what you commonly do, is you have 4 different bytes in an integer. That's basically how an integer is set up. 32 bits, 1 byte is just 8 bits, so we have room for 4 bytes there. And then we're going to use one of those bytes for the red component, 1 for the green, and 1 for the blue. Okay, and then if you wanted to, you could use the 4th one for this thing here, the alpha value, how transparent something would be, which would be totally possible, it's used like that at times, but I'm not going to bother about that. Okay, so what do we have here is the color, and then we want to give it the mask, okay, to add it together with. And what's that? Well, we could go with 255. That's the maximum number of a byte, right? If we don't think about it having a signed bit that is going to make a negative and so on. But if we just have 8 bits that is unsigned, then the maximum is 255. Okay, so I'm going to have 255 here, but I'm actually going to type it as 0xFF. We'll see later on why I'm going to do that. It's not going to do a difference in the code, it's just going to be sort of a reference of something that we're going to do in just a bit. Is this enough? Well, the red one is usually, well, that's what we're going to do, is going to be the 3rd byte from the least significant bit. So we need to move it up 2 bytes, right? So we get to the correct position. And that's what I'm going to do here. I'll move it up 16 bits, so that's 2 bytes, and therefore we get to the correct location. And then, of course, when we've done this and part here, we move it back down like this, so 16 bits down again. But however, we want to get it as a float to be from 0 to 1 instead from 0 to 255, and to do so I'm just going to divide it by 255 like so. So in the end we're now going to get the red part here in the same way that we got the red part sent to us before. And then we can just do the same thing here for the green part. but instead of going 16 bits up, I'm just going to go 8 bits up and 8 bits down, like so. And finally we can do the same thing for the blue part here, but that one is a bit easier, so we can just do core color. No, it's not called core color, it was called that in my notes, sorry about that. So what I want to do is 0xFF like that, and then divide it by 255 like so, and then I'm just going to add blue and green over here. Okay, so what I've done now is just compressed everything to one integer, and then we read that. We get the information by referring to the different bytes there. And this is not, like I said, something weird. This is very common that we represent each and every color part by 1 byte. That seems to make sense, 1 byte each. But also, since an integer has 4 bytes, what we could do is, of course, get the alpha value as the last one if we wanted to. And if we wanted to, we could just do 24 there and then refer to the alpha value over here. I'm not going to do that, but you can if you want to. Okay, so that's the first part. The second part is, of course, to fix these errors that we get. We get errors because, well, now we have different parameters that we need to give it. And I'm going to start with this droid item here, which had a dynamic color before. I'm not going to take that into consideration right now. It's very easy to do so, but just to show you this part here. So how do I define the color? Well, I can do something like this. 0xD300000. That's the color. Well, that seems a bit weird. Well, what we have here is, well, D3. What is that? Well, those are 2 hexadecimal digits. What does that mean? Well, each hexadecimal digit, is 4 bits. So 4 bits and 4 bits. For 2 of those are 8 bits. That's 1 byte, and each byte is representing 1 color part. So this is the red part. Here's the green part, and here's the blue part. So this is basically going to be a red color. Okay, that might look a bit weird, but no, this is how you do it. If you took course 4 when we work with interfaces, you might recognize that part. Let's take a look. So I'm just going to open the interface that we work with for the whole course 4, this GUI machine, and we can go back, well, down here to the foreground layer, and then we define the colors. Oh right, we're actually using the exact same color. Is that a coincidence? No, of course not. I used that on purpose. So what we have here, when we draw fonts in interfaces, then we define that with hexadecimal colors. So 0x here in the beginning to define that it's a hexadecimal, and then what we have here is the red part, the green part, and the blue part. So as we can see here in just this simple example, we wanted to have the red color if it was an invalid type, well, invalid amount of anvils. So basically, if this machine state was invalid, you don't have to think about it more if you didn't take that course. So then we want to have it red, otherwise gray. And it's very simple now. We can store that color here and then apply that when we draw it. If we had the 3 different components of it, what we would have to do would be to, well, write them all down. We would have 3 different variables that all would depend on if it would be invalid or not, and then we would have to give them all 3 here, and it would be quite annoying. So usually what you do is just store the whole thing in one integer, and to type it in an easy way we use hexadecimal notation there, so we don't have to do like 1 2 3 4 5 6 7 8. That's the red part. 1 2 3 4 5 6 7 8. That would be the green part, and then like 1 2 3 4 5 6 7 8. That would be the blue part. That's very tricky to read. So what we do is use hexadecimals like so to make it easier. But of course our code is not done. We fixed that in one location. Then we need to go to the render droid where we render the entity, and we need to update it here as well. And then I'm going to refer to get color instead, which of course doesn't exist. So let's create that one. Create method like so. There we go. And then we don't need the old ones here, like that. And we don't need these ones, and we don't need that one anymore. So what I'm going to do now is just define with an integer int color here. And I want to randomize that like before. Maybe you want to define it in a different way, but for now what we're doing here is just randomizing world.rand.nextInt like so. Now it's an integer we're working with, and what I want to do is define the maximum value that we have. What's the maximum value that we can have? Well, 0xFF. So that's the maximum we can have. Unfortunately, it won't look this good in the end, because what we have is actually when we randomize a number using rand.nextInt like that. It can't be the number we define. It can be the numbers below it, but not that actual number. So if we want to keep it with 0x ffff, yeah, you know that bit, we'll have to add 1 like that, which we can do. Or if we wanted to, we can just do a 1 there, and then we replace all the f's with zeros. Like that. That's the correct amount. And then we remove that part. Yes, because when you do nextInt, we can't get the one we're actually defining, just the ones below there. And then it's just a matter of returning the color here. So as you can see, now we don't have to bother about 3 different methods. We can get the color there. We can call that from different locations. If we have a long calculation for calculating the colors, now we just return the one we have saved. Then of course we just have to do that once. We don't have to do that in 3 different methods and so on. So it basically becomes easier to handle. And this was just an example of how we can work with bitwise operators there. And we saw an example of where it could become very handy to use hexadecimals as well. If we wanted, we can take a look actually. Here we go. If everything works alright, we shouldn't see a difference. If we see a difference, then we have failed completely somewhere along the way. But as you can see, we still have the colors here. We have different colors because they aren't saved. That was an issue I talked about in the previous course. Well, not an issue, just something that I never implemented. Like that. There we go. Awesome. So, what now? Well, I'm just going to leave you with one more thing. I'm not going to do it, I'm just going to mention it, and then we're going to end this lecture and this course. So, in course number 4, lecture number 3, or whichever lecture that was, lecture number 4 I think actually, then what we had was this thing here. When we synchronized the data from the server to the client, then what we did was send 49 different Boolean values. But what we know now is that we can just compress them into, individual bits that we put together into shorts, because when you send data here, what you do is send shorts, and therefore we wouldn't have to send as much data. But this is a similar thing to what we did in the last lecture when we had this compact boolean thingy, and you can just do the same thing with shorts, so you can store 16 at a time. What we could do then is just store 3, use 3 of those, and that would give us 48, one more. But then we could store the last bit together with the machine's height setting here. So instead of sending 50 values, we would be able to send 4. That's quite an improvement, don't you think? But I'm not going to have time to do that, so that's going to be sort of an extra exercise for you if you want to improve this when we synchronize the data with the interfaces. That's from course 4. Then we can do so. Instead of sending 50 values, we just send 4 of those values instead. So there we go. But let's take a look on the summary here before we end. It's quite short, but here we go. So in the beginning, what we did was using the metadata, which usually just stores 4 bits. Well, always stores 4 bits, but usually we use that value to go from 0 to 15. But here we use that to have a color, which goes from 0 to 3, and a side, which goes from 0 to 3 as well. And we just use the mask there to get it, and in the case of the side, we actually move it 2 steps to the right as well to move it down, so we get the side properly. And then we can just use it. In this example here, we use it for the icons to return that properly. Like that. And then when we want to modify it, we could do something like this. So here's where we modify the side. We get the metadata, we remove the old side, we apply the new side, and we set the new metadata to be part of the block there. And this is similar things that we've seen in previous lectures, where we remove the old data and set the new data like so, using those bit operators there, like that. Then we saw an example of how we can do it with items. So here we have, depending on the damage value, we're defining, for instance, how many uses we have left for a specific color and which color is the active one. And also what we had to keep in mind was to set a proper default value if we didn't want a 0 to be the default value when we got it from the creative window. So I just overriding get sub items there and adding a item stack with that long binary sequence there for the not metadata, but the damage value. And of course, if you wanted to add a crafting recipe, then you would just use the same item stack as I do here. You would do new item stack, give it the ID 1, and then the metadata like so. So we'll have to define that there as well if we want to add a crafting recipe. Nothing tricky. And then the last thing we saw here was how we could compress the colors into one integer, and then we could very easily just define that in hexadecimal, so we got like a color like the one we can see there at the bottom in the comment, 0xD30000, and that's just because it's going to be easy to write and easy to read and easy to work with, easy to send along, and so on. So we have one integer for those like that. Pretty straightforward there, I think. But that's pretty much it for today. Don't forget the questions and exercises, questions to see if you have learned the different parts of this lecture, and the exercises to practice that a bit more. Then we have the further explorations, where you can go even further than the other things, so maybe we go even further than the lecture itself. Then we have answers to the questions, of course, and possible solutions to the exercises in the end of the document. But of course, since this is the last lecture of the course, we also have an assignment, and the thing is, with the assignment, you do that, you send in the result to me, I'm going to mark it, everything's alright, you pass the course. If everything is not alright, I will send it back to you, give you some feedback, and then you can fix it. You'll send it back into me again. If it's wrong that time as well, I'm just going to send it back to you with some new feedback, and so on until you pass the course like that, so you can't really fail the course. And that's pretty much it. This has been Bits and Pieces, lecture number 3, Minecraft Bit Magic. I've been VSWE. This has also been the whole course Bits and Pieces, and this has also been all the 6 courses these past 45 days. So this is the last of the original lectures and original courses, but you might want to keep an eye out for behind the scenes and a final thoughts video that is going to be released a few hours after this lecture has been finished. So if you're watching this lecture recorded, then that video might already have been released. So take a look at that if you're interested in this project, what is going to happen with this project in the future, and how it goes with some frequently asked questions like, can I still hand in assignments later on? And that answer I can answer that question right away, and of course you can. But more information in that video, so keep an eye out for that. But that's pretty much it. I hope you enjoyed this lecture, this course, and all the different courses. Goodbye.